Good morning. Today we're going to be looking at exploring side angle relationships in trigonometry. We're going to start with reviewing things that you've already seen before last year, and then beginning to explore two new concepts. Today's concept is going to be the sine law. But before we get there, let's review. Our learning outcome today was going to be exploring the relationship between each side of an acute triangle. And an acute triangle, remember, is a triangle that has angles all less than 90 degrees. And the sine of its opposite angle. What's the relationship with sine of its opposite angle? When we calculate the measure of all the angles and all the lengths in a right triangle, we solve the triangle. We can use any of the following three primary trig functions or trig ratios. And that would be using sine, cosine, and tan. And the basic strategy is the following. Notice where the acute angle is and label the sides opposite, adjacent, and hypotenuse. And it's all based on where we're looking from. So in this first example here, we are going to be looking from angle A. So if we were to label it from angle A, it will be different than if we were to label it from angle C. Next, we notice what is given and what you need to solve. Lastly, decide on a trig ratio that is going to be used to solve it, often using SOH CAH TOA, knowing that S is sine and it represents opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tan is opposite over adjacent, which are all written right over here. Hypotenuse is another fancy word for just the longest side of a right angle triangle. Opposite is opposite to the angle, the side opposite to the angle, and adjacent is a word that actually does mean beside in English. So if we were to take this triangle here and label it, based on this angle, this would be the opposite side right over here. Where's the hypotenuse? You guessed it. It's opposite the right angle. Hypotenuse. There we go. Just look up there how to spell it. And lastly, what's the side beside this angle that's not the hypotenuse? It would be the adjacent side. It's also the only remaining side left on this triangle. So we've labeled all the sides. So we notice where the acute angle is. There's two of them. So we could look at it from this angle or this angle. If we're looking from angle A, that's what we're going to need to do. In order to solve this, what are we going to all be solving here? Well, let's solve for a variety of things. It says solve the following triangle. So we're going to solve a couple things. We're going to solve this length, and we're going to solve for this angle, and we can also solve for this angle right over here. So let's start with the one that you would probably remember the easiest. Let's solve for this longest side right over here. So technically, when you're looking at sides and you have an angle over here being capital A, this side is actually going to be little a. So A is equal to 5. B, this is angle B. This would be side B. Angle C over here, this is side C. So yes, the Pythagorean relationship is normally a squared plus b squared equals c squared. But the c in the formula represents the longest side. Here, our longest side is B. So sorry to confuse you, it's just based on the way that this triangle has been labeled here. All right, that's the only difference right over there. So we're going to go, in this case, the longest side squared is equal to the other two sides squared. It's only based on what the triangle is giving us. So it's the longest side squared is equal to the sum of the other two sides squared. So we can now plug in our values. C squared is 12 squared and A squared is 5 squared. So 12 squared plus 5 squared. If you punch this on a calculator, you'll have 144 plus 25, which is 169. You will now figure out what is the opposite of squaring something. And the answer to that is actually taking the square root. And the ultimate goal is to get just b, isolate that variable. And so to do that, you have to undo the square by doing the square root. If you do the square root on the left side, you also have to do it on the right side. What you end up getting is the square root of 169 is actually 13. You punch that in on your calculator, you should get 13. And then we finish that answer by writing centimeters. And we've solved one of the sides now. So B is equal to 13 centimeters. Next, let's look for angle A. Looking at angle A is a review of SOH CAH TOA. To solve for angle A, let's use the values that we did already know. We knew the opposite side, we knew the adjacent side. So we look to here to say which one has opposite and adjacent. It's tan. And the way that these also should go too is that it's not just like sine is equal to opposite over that. It's actually going to be sine theta. Sine of the angle is equal to opposite over hypotenuse. Cos theta, cos of an angle is equal to adjacent over hypotenuse. Tan of an angle is equal to opposite over adjacent. So if we were to write that out over here, tan of an unknown angle, so we call it A in this case. So we could call it theta, but let's label it correctly, is equal to the opposite side over the adjacent side, 5 over 12. Now, if you remember back to calculating angles, the way in which to do that is you need to isolate your angle. Our angle is over here. The only way to get this to the other side is by actually taking the inverse and swapping the ratio with the angle. And what you're left with is the inverse of tan of 5/12 is equal to A. Now, how to punch that in on a calculator is the following. First of all, make sure that you are in degrees mode. If you're not, then you might need to punch on your calculator here and choose degrees, not radians, not gradians. Next, if you want to punch in tan, the inverse of tan, this is just regular tan. To punch in the inverse of tan, you first push the second function button, which you now see up over there. Now it's the tan button, followed by your fraction or ratio, 5/12. Close your brackets, push equals, and you're going to get 22.6 degrees. So A is equal to 22.6, which rounds to 23 degrees. Our units are degrees. We can now solve for C actually using the rules that we already learned from our last unit. If this is 23 degrees, if that is 90 degrees, we can find C. C is just going to be 180 degrees minus 90 minus 23. 180 minus 90 minus 23 equals 67 degrees. So C is equal to 67 degrees. And we've now solved for everything on this triangle here, this side and these two angles. If you need to pause, you can pause the video at any point. We're now going to be solving for the next piece. Luckily, this time we labeled it a little bit nicer. We have C over here, so our side C, little c, is going to be over here on the hypotenuse. And then we have side B over here, and we're going to have side A over here. So it's opposite to whatever angle is being labeled over there. So we've labeled all of our sides now. The next thing to do is to identify. We're going to be looking at this angle here, from this angle. So I unfortunately drew over that number, it's 42. We're looking from B here. So that's our vantage point. So looking from B, label these sides. I'll give you a moment to try to do that. Pause the video. Opposite to this angle is B. Beside this angle is the adjacent side. And over here, the longest side, opposite to the 90-degree angle, is our hypotenuse. So we have an angle, and we have two sides that we need to solve for, and we have one side we do know. So when solving for unknown sides, so whether for B or for A, we're going to be using the hypotenuse. So it's going to be either the A in the hypotenuse or B in the hypotenuse. So let's start alphabetically. Let's go with A. So which trig ratio, if you're writing them out again, SOH CAH TOA, has adjacent and hypotenuse? Well, adjacent and hypotenuse, that would be cosine. So we're going to write that as the follows. Cos of this angle, 42 degrees, is equal to the adjacent side, which we do not know, over the hypotenuse, which is 22. So we have to go about solving, and we can solve this two different ways, if you remember. And maybe your previous teacher only taught you one way. I'll show you both of them. One of the ways is writing this as a fraction. Anytime you have a number, you can write it over 1 and create a fraction, because this number is the same thing over 1 or without the 1. And so now you could go cross multiply, then divide. So A would be 22 cos 42, where you're multiplying the 22 by cos 42. And then you would divide by 1. So cross multiply, then divide. So if we divide by 1, we're still going to get that exact same number. So we will punch that in on our calculator here. We have 22. And the way that this particular calculator works is you don't actually need to push the multiply sign. You can just directly go cos 42, close your brackets, and you will get a side of 16. So 16, and what are our units? Our units are centimeters, 16 centimeters. The second way you could go about doing this is as follows. So let's rewrite that just on the side here. Cos 42 degrees is equal to A over 22. The second way to solve this without using this ratio here, and again, you can use this method or this one. This way is isolating the variable. If you see A over here and you want to isolate the variable, you want to get rid of this 22. What is this 22 doing to the A? Well, it's dividing it. So you want to do the opposite operation, and you'll do that to both sides. So we're going to multiply this side by 22, getting rid of these, and we'll multiply this side by 22. And what you're left with, look at that, 22 cos 42, the same as this one right over here. And so then your steps just follow, and you're going to be left with 16 centimeters as well. Let's take a look at side B now. We still know side C being 22. We do know, or we want to know B, and we still know this angle. So which ratio uses opposite and hypotenuse? It's going to be SOH, which stands for sine, is opposite over hypotenuse. So sine of this angle, 42 degrees, is equal to the opposite side, B, over the hypotenuse, also 22. If you notice, this is the variable is in the exact same spot as this one right over here. So again, what we're going to do is just put this over 1, cross multiply, then divide. So it's going to be B is equal to 22 sine 42. And this time, I'm not going to show dividing by 1. Cross multiply, divide by 1. If there's a 1 on the bottom here, I'm not going to write in divide by 1. So you should know cross multiply, then divide. I will, I guess, write it one more time here, but you're going to get the answer here. I don't think I even punched it in last time. And I will definitely not punch it in on my calculator here either. If I go 22 sine 42, divide by 1, you get the same number here. So if we round this to the nearest whole number, we're going to get 15 centimeters. So we got our answer for A, we got our answer for B, and the last thing to do is to find our angle A. And so remember, all three angles add up to 180 degrees. So A will be 180 degrees minus our other two angles, 90 and 42. Punch that in on your calculator. Again, 180 minus 90 is just going to give you 90. So you can actually have that as a starting point. 90 take away 40 is 50. Take away 2 is 48 degrees. We've now solved all of them, the two sides as well as the angle. That's just a quick review of things that we've done in the past, or at least you've done in the past in prior years. If you haven't remembered this as well as you'd like to, you can always look up more examples online, as there's lots of examples that would work with this right here. Given the following triangle and its measurements, what are two equivalent expressions that represent the height of triangle ABC? So this time, the hint already is use the sine ratio. And so if you were to look from angle B right over here, and you had a particular height, here is the hypotenuse. This is a right angle triangle. remember, the SOH CAH TOA only actually works for right-angled triangles. So be aware that if you have a triangle that's not a right-angled triangle, which this big triangle is exactly that, it's not a right-angled triangle. This small one right over, this one over here, the smaller one to the big one is one, and this really small one also is a right-angled triangle too, right over here. But this other one is not. So let's look at this medium-sized triangle here. The opposite side is h. The hypotenuse is 51.2. So if we were to say, what are two equivalent expressions that represent the height of triangle ABC? In this particular case, one of them is going to be right over here. Let's say that again. What are two equivalent expressions that represent the height of ABC? So let's write this out here. We're going to have sine of 46.5 is equal to opposite over hypotenuse 51.2. This is one example, and so now we're going to isolate our variable in this case because instead of the cross multiplication way, we want to say, well, what does h equal? So the way to do that is to multiply both sides by 51.2. And then I'm just going to write it out what that looks like then. It gets rid of it on this side, and then the 51.2 comes to the front of this right here. So this is one particular way of writing that right here. 51.2 sine 46.5. H also, if you're looking from this angle right here, now we have an angle of 83.3 and opposite over hypotenuse. So we could also express h in this way. Sine of 83.3 is equal to our opposite side over the hypotenuse. Again, this time we're going to multiply by 37.3 on both sides to get rid of it on the bottom here. And we're going to have 37.3 on this side, because remember, if you multiply it on both sides, you cancel it here, leaving it in the front over here. So sine 37.3 multiplied by, 37.3 multiplied by sine 83.3. And now we have two values that are equal to each other, two equivalent expressions. So you could actually say that 51.2 sine 46.5 is equal to 37.3 sine 83.3. Let's just, calculate that out quickly. What does that look like as an actual value? I'm curious. We're going to get 37.1 for the first one. Let's look at the second one, 37.3 sine 83.3. And we're also going to get 37. So in both cases here, we're getting a height of 37. So our height is 37 centimeters. And that's also accurate in the sense that our hypotenuse here is 37.3, so it's longer than this height. So that is a good thing. Using the sine ratio shows the relationship of two triangles. What can we conclude from our two equivalent expressions over here? So we have two expressions, perfect. We have this value here, this value over here. They're both equal to each other, right? They're both equal to each other. This one's 37. The other one was 37 as well when we actually calculated that out. So we're able to actually conclude that from our two equivalent expressions, they are indeed equal. Even though you're dealing with a little bit of a different angle in both cases. You have a different angle here, different angle there, but that also is represented by the fact that you have a different side over here and a different side over there as well. So there's a couple little differences with both of those. Let's take a look at what that actually means. So if we were to actually compare the ratio of the length of opposite side versus our sine angle, our equivalent for the side angle pairs in the acute triangles, if we were to actually do a comparison here of the ratios of the length of opposite sides to the sine angle, let's see what we actually come up with. So just for food for thought here. So what was the first one? Length of our opposite side. Let's do the big triangle. The opposite side was actually the same in both cases there. The length of the opposite side was what our h value was. Our h value was 37. And so then what is that? The sine of that particular angle there. So 37 over sine 46.5. And the other one was 37 over sine 83.3. So both cases, those are the opposite sides. In this case here, we're going to get some very different values here. If we did 37 divided by sine 46.5, we would get a value of 51. And on the other side there, if we did 37, and I can just show you what's happening here, divided by, in brackets, I should maybe have closed that. Hopefully it doesn't make a difference. When you're doing this, when you have dividing with a trig ratio as well as an angle, you do need to include brackets in front, just so that you're going to get the correct answer, 83.3. Close those brackets. In this case, we're going to get 37. Let's see. I just want to double check that other one there to see if I actually punched that one in correctly there. Yeah, 51. Okay, perfect. And the last one, if we looked at 37.3 actually. So, and look what those represent actually. So this ratio right here ends up being the hypotenuse over here for the one side. And then on the other one, this ratio was the hypotenuse of the other side. So interesting how that actually works out there, these two ratios, creating the hypotenuse for each. So we're going to be looking at working out what is the sine law and how can we actually use it then. So if we're given this particular triangle right over here, this is not a 90-degree angle triangle. So if you were asked, can we solve this triangle using the SOH CAH TOA, the primary trig ratios with the given information? You should have remembered earlier in the lesson that no, you can't. No. And why? Big question here. Why? What did I say before? It's not a right angle triangle. So SOH CAH TOA works for right angle triangles. If it's not a right angle triangle, you can no longer just use SOH CAH TOA. There are many examples of triangles that are not right angles. So in those cases, you're going to have to come up with a different way to solve. Right here we have an angle. We have an angle. So we could solve for this angle right over here. That's something that we can do. But how are we going to solve for side C over here? So remember, capital C for our corners and angles. Opposite to that is the lowercase side. So this is side C. Opposite to angle B, this would be side B. And over here, opposite to A is side A. So we're given this, and we're going to be solving this on the other side. Well, the formula and the equation is over here. To solve, we're going to use either the sine law or the cosine law. So there's times in which you don't have the information to use the sine law, so you have to use the cosine. And there's going to be situations in which the sine law is just easier to use, and so that's the one we choose. It looks like this. The sine law is as follows. It's the sine of angle A divided by side A is equal to sine B divided by side B. So if you look over here, this angle right over here, we could say, well, sine A divided by side A is equal to sine B, which is sine of 58, divided by 16. And then we could then solve for our unknown variable. Right now, there are two pieces we don't know. We don't know angle A and we don't know side A. So we actually have to figure out angle A first, which is quite easy to do because we have two angles. And then afterwards, we could solve for side A. So let's take a look at what we actually need to do. If we look over on page 4 here, it says we're going to use the sine law in a variety of situations. So situation number 1, when we're dealing with a non-right angle triangle. This is a non-right angle triangle. Well, the second option when we use the sine law is when we're given an angle side pair. So if we look across over here, we are given an angle side pair. We know angle B, and we also know side B. So the moment we have one pairing and we know one other piece of information, whatever that is, whether it's an angle or one of these other sides, either side C, side A, or angle A, we're able to solve the rest of this triangle using the sine law. And let's go ahead and do that. It says solve for this triangle right over here. So we're going to solve for that right now. Let's start by solving for side C. And then afterwards, we're going to be solving side A. So side C is a little bit easier, so let's start with that one. The way we're going to solve for side C is exactly using that same formula. It's going to be sine B over B is equal to sine C over C. And you ask, whoa, before the formula was sine A over A is equal to sine B over B. Yes, of course. But look at what we're given here. We have one pair angle relationship right here. So I'm immediately writing that one down right over here. Sine B over B is this angle relationship. And I told you we are looking to solve for side C, and we know angle C. So that's why I have this one here. We're going to be looking to solve for just this on the bottom over here. So let's begin plugging in our values then. Sine B is the same as sine of 58 degrees. Side B is 16. Sine of C is this 62 degrees here, so sine of 62. All divided by C. Now, when you have two fractions, two ratios, you're going to cross multiply, then divide. So these are the two values that are across from each other, and then you will multiply them, followed by dividing this. So C will be equal to 16 sine 62, all divided by sine 58. Cross multiply, then divide. So if we punch that in on our calculator, what we end up getting is 16 sine 62. Close this bracket. Be very, very wise to close this bracket, especially if you have this calculator here. Divided by, and then in brackets here, I'm going to go sine of 58, and it automatically opens up a second set. So I'm closing the first set for the angle, and then the second for the whole bottom there. And then I get a value of 16.7. 16.7. So side C over here, 16.7. We don't have any units, so let's just say that this was meters, and we'll have meters for C as well. Next, in order to solve for A, there's one problem though, and that's we don't know angle A, at least not yet. But we do know these other two angles. So if you remember, angle A would be equal to 180 degrees minus 58 degrees minus 62 degrees. So clear that. 180 minus 58 minus 62. A would be 60 degrees. Now that we know that A is 60 degrees, we can go ahead and solve. We have an angle. We need to find this. We still know these two. Use the pairs that are given to you when possible. So this time our formula will be like this. Sine B over side B equals sine A over side A. And we can now plug in our values. These are the same values on this side. So sine 58 over 16 is equal to sine 60. We just calculate this angle over side A. Again, we're going to solve for side A. How do you do that? You cross multiply, then divide. So you cross multiply, 16 times sine 60 is 16 sine 60, and then we divide by sine 58 degrees to solve for A. And that's going to look like this, 16 sine 60, close the brackets. And if you really wanted to, you could also push an equal sign there too, and then divide by sine 58, close the brackets, equals, in this case, 16.3. So it seems like it's the same length as this other one right over here, very, very close, which should make sense. If this is 58, that's 62, that's 60. It's almost an equilateral triangle, so all these sides should be relatively very, very close to each other. And if we take a look, 16.3, 16, and 16.7, with the smallest angle giving us the smallest side. 62 degrees is the next, is the largest, and look what it gives us. It gives us 16.7, the largest side. So the largest angle goes with the largest side. So these are things to think about when you are making your calculations. Do these calculations make sense? They make sense if you are following logic. So make sure to follow logic. The smallest angle is going to make the smallest side. And that's why in the past, when you had the Pythagorean relationship with a right angle, the opposite to the right angle was the hypotenuse. The hypotenuse was always the largest side because the 90-degree angle was the largest angle. So it was actually based on the angle. So here, the 62-degree angle is going to make the largest side right over here. So C, in this case, will be the largest side. All right, the next example. We have a variety of sides. Opposite of angle A is side A. Opposite of angle B is side B. Opposite of angle C is side C. We have two angles, 62, 75. So I often like to start with finding what I need to know or do know right away. Let's look with this angle. So last time we didn't do that right away, but here we have two angles. Let's just solve for C right away. Because we will need to solve for side A. So technically we don't even need to solve for C. So if you are reading this carefully, you don't necessarily always need to solve for that. So I'm just doing this out of practice just to say, okay, let's say, how do you solve for this angle? You're going to go and remove these other two angles from 180 degrees. And what you get is 180 minus 75 minus 62. And you're going to get 43 degrees. So kind of irrelevant based on the fact that we do have a pairing already. We have an angle pairing, 75 with 15. So with one angle pairing, and we already know one other angle here, we can solve for A. So let's do that. Sine A over A equals sine B over B. And as you see in the last formula, I actually wrote it the opposite way. It doesn't matter. 3 equals 3 either which way, or x equals 3, 3 equals x. It doesn't matter how you write it, which one goes first. So on the next line, we're going to plug in our values that we do know. We don't know A, sine 75 over 15. Here's our value. So again, you cross multiply, then divide. We're going to get 15 sine 62 over sine 75. And then let's solve for A. It'll be 15 sine 62. Close the brackets, and then sine 75. 13.7. 13.7. And our units are centimeters. And let's just take a quick look. Does that make sense? This angle is less than 75. This side is less than 15. It's only 13.7, so it's less than 15. This makes sense. This is congruent. And so please keep asking yourself those types of questions. Does this make sense? If it doesn't make sense, you might have punched something in wrong, or the degrees might be off too. Like it says degrees are right over here. And so if it is saying radians or gradients by saying rad or grad, you need to change that if you think you punched it incorrectly. If not, it's probably one of those things where you either forgot some of those brackets in the right spot there. So just be aware of that as well. That's another option of where you might have made a mistake on the punching it in if you feel like you had all the right numbers. Let's solve another triangle here, DEF. We have two angles here. We can solve for this one there, but let's take a look and see what actually needs to be done. We're going to use the law of sine. You must first find the measure of angle E. So perfect. We know these two. Let's solve for E right away. E is just going to be 180 minus 49 minus 71. 180 minus 49 minus 71 is 60 degrees. Easy enough. We can label that in here too. Now we have one pairing. We have an angle pairing. Angle, side. That's what we need if we're going to want to use the sine law. And now we can solve for d first. So we'll be looking across over here. So let's write that down. Sine d over side d is equal to, we're going to use this one because we have the pairing here. Sine e over side e. Plug in what you know. Sine of 49 is equal, over d, we don't know what d is, equals sine of 60, which we just calculated, over 54. We'll pull that up. Now cross multiply, then divide. Cross multiply is 54 times sine 49, all divided by sine 60. So 54 sine 49 divided by sine 60 is 47.1. And we have centimeters. Let's take a quick look. Does this make sense? Does our math make sense? So we look back to over here and we say, okay, a 60-degree angle gives us a side of 54. If we have a 49-degree angle, that's going to be less than 60, so our side should be less than 54. It is less than 54, it's 47.1. This angle of 71 degrees, when we calculate f, should be much more than the 54. If 60 degrees gives us 54, if 49 gives us 47, 71 should give us something larger too, right? So it seems that each side is smaller than the angle. So 54 is smaller than 60, this one was smaller than that. So if you were to make a guess, maybe 66 centimeters. Let's take a look at what it ends up being. So to solve for f, we're going to go sine of angle f over side f is equal to sine of e over side e. And so this one here, I'm using the exact same as I did in the prior example there, here and there. These are what was given to us. Well, we solved for e first, angle e, and we knew what side e was. So sine of 71 degrees over side f is equal to sine of 60 degrees over 54. Cross multiply, then divide. 54 times sine 71 divided by sine 60. Sine 71 divided by sine 60 is equal to 58.96. When we round this to one decimal place, f becomes 59.0 centimeters. So my 66 was off by a little bit, but it's still close. It's in the sense that it's more than 47, more than the 54, but it wasn't as much as I thought it might be. All right, and that solves these ones. We have what f is equal to, 59.0 centimeters. We have the previous example where d was 47.1 centimeters, and we calculated angle e up above at 60 degrees. So let's do a little recap here. What ended up happening or transpiring today? Well, the sine law can be used to determine unknown side lengths or angle measures in acute triangles. You can use the sine law to solve a problem modeled when you know the variety of things here. Two sides and an angle. Opposite a side is known. So if you knew this angle right here, you know the opposite side right over here. So this is one pairing. Well, then you can go ahead and solve for any of the other unknowns then. You can first of all solve for this angle here, knowing this side. At which point, once you know this angle, well, two angles, you can use the sum of 180 degrees for a whole triangle to solve for this one. And once you know this angle, then you can solve for the last one right over there. Two angles and any side. Well, two angles and any side is good because this is the most difficult of them all, in which you don't technically know this angle just yet. Well, you know these two. If you know these two, this one here is just going to be that 180 degrees minus whatever this is, and then minus whatever this is. And that's going to give you your final answer, right? So once you have this angle, now you have an angle side pairing. You just need one angle side pairing. So this one here, you had it right off the bat. Oh, sorry, right over here, you had that right off the bat, and then you were able to solve for this one, etc. So if you know the measure of two angles in a triangle, you can always determine the third by subtracting from 180, as I mentioned over here. That concludes our lesson. It's a lot of information to take on. If you need to rewatch this or to pause the video, please do so that you're able to develop a deeper understanding of how to solve for an unknown side or an unknown angle using a triangle that's a non-right angle triangle. And as well, you should also still remember how to calculate a right angle triangle using sine, cosine, and tangent. And so if that's something that you need to do, then look back to the beginning of that where we went through SOH CAH TOA. With that, good luck and have fun.